Happy Aloha Friday. This is Kaui Lucas on Hawaii is My Mainland here at Think Tech Hawaii. This afternoon I have Dr. Reza Ghorbani from UH's Renewable Energy Design Lab, the RED Lab. And I invited him because a few months ago he gave a talk at UH and explaining the smart grid, and I thought, this is really very useful information, not this little select group of about 50 people gathered in Sinclair Library need to know this. We all need to know this on Hawaii. And so here he is. Thank you so much for coming down.
Thanks for having me here.
Okay, so I don't think the governor had actually made I'm not sure whether he had made that announcement when I first saw you. But anyway, 2047 is now the due date to be weaned off of fossil fuels here in Hawaii. And there's current legislation pending. House Bill 2085 has made the crossover. Mm-hmm. And next Tuesday is going to be, March 15th is going to be heard. So I will, of course, have the follow-up information from our discussion at kauilucas.com so people can check for links and go ahead. So, and submit testimony for Tuesday. I don't think we have to explain to anybody really why it's important or necessary to be weaned off of fossil fuels. Let's just get into how can we, is this for real? I mean, how do we make this a reality? 2045.
2045. Hawaii has a unique opportunity to be an energy independent, fossil fuel independent, and combining the current energy situations that we have with future plans and combining that with electric transportation, electrifying the mobility, on land mobility, is a great opportunity, I think, to help the electricity grid to get off fossil fuel. However, it's extremely challenging. It's the way that the electricity network works, the way the generation and distribution works, and the way the whole protection system and operation and control works is completely different than the way that is gonna be working in 2045.
So there's a lot of transition that needs to happen.
There is lots of transitions, exactly, and that has to do with any sector of energy, energy generation, distribution, storage especially, and also the smart grid communication, and the demand response, and invention of smart appliances, adaptive appliances in your houses, and also other hybrid combination of using the different energy. Yes, definitely we are going through a metamorphosis of electricity grid in Hawaii.
Do you feel like it's possible to get there by 2045?
I think technically it's possible, but you have to think that sometimes you have bad weathers, okay? So, and this is about the energy, okay? So in bad weathers means that you might have 40 days of cloud, no wind, and so perhaps the main energy supply of the grid will be solar and wind, mainly solar, and then wind, a little bit of biomass, might be a little bit of wave energy, and some other type of energy. So in order to, you cannot store 40 days of energy,
solar energy.
You cannot.
Right,
It needs huge amount of investment. It needs, it's very, very expensive, okay? So.
Storage is expensive.
Storage is very expensive. Okay. Storage is very expensive.
Because the solar.
And it's gonna be cheaper. The technologies are evolving. They're, much more reliable, and it's gonna be cheaper hopefully by 2045 or maybe even 2030. so you can rely on a big storage systems. But still, it's extremely challenging if you want to store all of your energy from. So planning to go 100% renewable, it requires a great deal of optimization, a great deal of understanding the climate, the microclimates, understanding the behavior, understanding what kind of load you have, understanding what flexibility you have, and optimizing everything and minimize the cost, improve the reliability, and so on. So it's a very, very challenging problem to solve. If it was a small island with 10 houses, it was much easier to solve than 300,000 residents and other businesses and loads. So, and we have critical loads like emergencies, hospitals. You have to make sure you always have good supply. So my understanding is, in a normal life,
Yeah,
in a good, we can have 100% renewable, but sometimes we have to rely on something else. Sometimes we have to have we have to have backups from fossil fuels or biomass from combustion-based generations, from maybe very advanced and new technologies of storage that can store huge amount of energy in a small volume and with very reliable. So it's extremely challenging, but the grid needs to be evolved, and you have to go through a couple of major steps in order to be even close to 100% renewable. It's extremely challenging. It needs a huge amount of innovation. It needs lots of passion. It needs lots of dedication. It needs it needs investment. And we know that renewables are much cheaper than fossil fuels anyway. It's a natural way. In a couple of years, the technologies are in a way that wind and solar are so cheap that it doesn't make sense anymore to go non-renewable. It wasn't like this 5 years ago. It is today. So it doesn't make sense to go non-renewable. That's very, very important. And the market goes when it makes sense for more people.
And we're learning to do our math a little bit. Or
Okay.
When we talked in the past, you were talking about how, there is, even though it's very dirty, there is certain advantages to coal in that it's so cheap. But I was reading last night about how the cleanup for that cheap coal is now becoming prohibitively expensive when the government insists that those coal producers do actually pay what it cost to clean it up. So that's the other side.
Environmental impact.
The environmental, when we add that to the cost of generation, then it makes it even more cost effective.
Right.
And we probably shouldn't be spending millions of dollars fixing or upgrading our coal burning facility out at Campbell Industrial Park. A lot of people don't know, but Oahu gets 20% of its electrical generation from that coal plant. And why would we spend more money now upgrading that when we can do some of the things that you suggest?
That's a good point. But on the other hand, in order to transit from, coal is very cheap compared to other stuff that we're burning right now. So you have to transit from fossil fuel-based generation to non-fossil fuel-based generations, and we want to go smoothly. We want to go with less huge issues. We want to go. So you have to study. You have to study the investment that you put for the coal power plants or any other power plants replacements, gas power plants, the fast ramping turbines, or new technologies. So in conventional generation, you have to see the big picture, and you have to see the vision on what's the main milestones, how do you address it, and how you get there. So if I didn't do that calculations for the coal power plant, so I'm not sure if it makes sense or it doesn't make sense. Definitely, I personally prefer renewables to non-renewables. So
Yeah, and we're as you said, we're moving that way. It's going to make more and more sense. And so, but what to the average homeowner? Let's just
Right.
take it down
Okay.
to maybe the neighborhood scale.
Mm-hmm.
It's so hard to talk about because there's so many systems involved. You talked about the balance of generation and demand, and how is, can you talk about it in a way that can describe to people listening what that might look like?
Let me explain briefly how the system works now. The system works in a way that you have generators in a couple of different places in the islands, the big generators, the coal power plant, the diesel generations, gas turbines. So biofuels, you have different type of generations, wind turbines, so concentrated solar power. So what happens here, that power goes from this main generator through transmission lines to substations, redistributed in the substations after transformers to the distribution to the different feeders, and then after that it distribute to your to pole top transformers, small transformers, and then goes to the houses. Okay, so the old mentality, or the way that they actually manage the whole balance, is they predict the load. Okay.
So right now,
HECO
knows
HECO
how,
knows,
thinks it knows
yes,
what
they
we're
have
going to use.
Yes.
Okay.
They know what they need to produce for tomorrow, and based on that, they dispatch. They plan which generations goes on and which generations goes off, when and how much, to optimize, to minimize the amount of fuel that they're burning. Okay, and so these are their prediction. Based on that, some generations comes on. Okay, and they're ready, they're working, and they try to manage the frequency of the system. Frequency is like your heart rate, right? So and locally in each generation, they try to manage keep the frequency constant. That means that if you keep the frequency constant, you keep the balance between whatever load comes to your grid, like water heaters, air conditioning units, new anything, your lights. So that they need to, in real time, they need to adjust it. They need to adjust it. And there's a controller, fast controllers in their generation units. They try to manage that one. Okay, so that's a traditional way of dealing with this with the grid. Okay, and it works very reliable. It works for over 100 years. I mean, and it will work. Okay, so now you add lots of PV in different places at people's houses, and you have no visibility what's going on, who is producing what. Okay, so you can't predict the sun. You can, I mean, the cloud coverage, but it's not really accurate. You can predict the wind, but it's not really accurate. So now you are dealing with lots of uncertainty. So in order to deal with these uncertainties, that means that maybe your loads, basically your distributed generation, which is the PVs, basically more
Distributed
PV
generation
is like PV, like photovoltaic that you put in your rooftops.
Okay.
And then the HECO doesn't have a visibility on those, right? And those goes up and down, right? Because clouds come and goes, right? And they have to manage this balance. So then they have to deal with these rampings, okay? Ramping up and down of the generation, because they try to manage the frequency. And the frequency is, a good frequency balance means that the load and generations are equal. Then it gives them lots of headache. I mean, it's really difficult to deal with it, because traditionally those generation units are not built to deal with those fatigue, with those up and down, quick up and down. So now they have to invent new technologies, which is the atomizing the burners and steam, putting steam as part of the fuel that they are injecting to their burners, to make sure that they can go up and down very fast. And so to make sure that they are ready to deal with the day-to-day changes of this, adding more renewables. It is difficult.
It is difficult?
It is difficult.
Okay. So maybe we'll take a little break and come back and see if we can come up with a solution in a minute.
Sure.
Hi, I'm Donna Blanchard. I'm the host of Center Stage here on Think Tech Hawaii. Center Stage airs every Wednesday at 2 o'clock, and of course you can check out our archives on YouTube or on Think Tech Hawaii anytime you like. Why should you do that? Because this is an arts show that I believe is making a difference in lives. We talk with artists of various ilk. We talk with painters and writers, playwrights, novelists, poets, sculptors, dancers, you name it, directors, actors, of course. And we don't only talk about what people do, but we talk about how they do it. And my favorite part of the conversation, we talk about why they do it. And it's really common on this show to hear people say, wow, I didn't think about it that way. And it's very common to hear people afterwards who have seen the show say the same thing. And I hear all the time that people are inspired by the conversations that we have. So why don't you join us and be inspired too? That's Center Stage on Wednesdays at 2 o'clock. We'll see you Center Stage.
Aloha, welcome back to Hawaii is My Mainland. I'm Kaui Lucas, and with me today is Dr. Reza Ghorbani from the Renewable Energy Design Lab, the Red Lab. And we are talking about smart grids. And it's a big subject, but to just give us a sense of what this impending transition, this really exciting time here, that we get to be the guinea pigs in the most beautiful way, really.
Yes.
But to Mr. and Mrs. Lee, who've lived in their little house in Manoa for 60 years, and their water heater might be 20 years old. Maybe they have a couple panels, or how much is life going to change? What needs to happen for us to get to this goal that we really want to get to?
Okay, following up my previous discussions, okay?
Yeah. So it's hard for HECO to balance the fluctuating demands.
Right. So that burden of fluctuating demands needs to transfer to everybody that is generating now, because everybody has a rooftop and everybody has a generator. You have a generator in your rooftop, you have a photovoltaic
so that
panel.
That means that everybody should have a
and everybody, I mean, at the end of the story, everybody should have a PV.
That's an important thing to say. For you to say that, it's
also
a good thing.
For HECO, makes much more sense that if everybody has more PV in their rooftops, because the way that they will deal with the energy fluctuations becomes easier if there will be a mechanism to transfer part of the financial loads of these fluctuations to everybody that is generating at the rooftop.
Crowdsourced energy.
Exactly. It's a community now. Everybody's producing. Not everybody is responsible. So how does it work? It works based on different tariffs, based on different pricing. You have to design a better pricing system for everybody. So, but renewables like PV makes lots of sense, okay? And how does it work in future is, let's assume everybody has a small rooftop PV panel, okay? And then everybody's producing, and everybody will, in future, everybody needs to be able to do some transaction to the neighbor. Like, I need to be able to sell electricity to my neighbor or to anybody that has an electric car that comes onto my parking lots, rent my parking lots and plug into my PV. Or if my neighbor has a bigger battery to store, I need to be able to sell him and buy him from him. So we need to design a better or more liberal, actually, way of dealing with electricity exchange, okay? Because it's a power, it's a fast.
So does that need to happen in a decentralized way, sort of between you and your neighbor? Or is it more centralized and interconnected, or how does that happen?
It's a very challenging problem. It needs to be designed. It needs to be studied. It needs to be simulated, okay? But
Is that what happens in the Red Lab?
We're working on it. And lots of other people in the country and at UH are working on it. So it's a very challenging problem to find out what is the best approach. But from my experience and with what we are doing is, coming back to your first question, original question that you had. So maybe everybody will have a small battery pack in the home, okay? Because sometimes of the day, the electricity is very, very expensive to buy from anybody, from the utility or from your neighbor, so you rely on your small battery, okay? And then your loads, like water heaters that you mentioned, appliances becomes, more smart, smarter and smarter, because the companies that are selling, they are already thinking and they're already having products that the appliance, in a way, the appliances become more smart. That means the appliances can communicate with with a gateway somewhere in your house.
So
And that gateway
in the house.
in
So
the
it's-
house.
Okay. So
And that gateway is a small iPhone, okay, which
Okay.
is $20, okay, it's very cheap. But that phone or controller manages your own energy balance. It knows what you're doing, what you want to do, estimates that, it's intelligent, and based on that, it manages your battery and manages the controls of your water heaters, your appliances, and everything else, okay, that you have. So they communicate. The appliances become smart. Let's say your washing machine using a heater, okay, and the electricity price spikes up. You have no reserve, so you delay that heating for 1 more minute. You save a lot, okay?
wow, in 1 minute?
Because those are 1 minute and 1 minute are adding together, right?
Okay.
So in long term, the appliances save money for you.
Okay, so this is presupposing, you mentioned it earlier, tariffs. So
Yes.
different tariffs. So this whole structure you're talking about means that there isn't going to be a single so many cents per kilowatt
Yeah.
anymore. It's going to be dependent on the time of day.
Yes, it's going to.
Or something.
Is going to be more variable, the pricing, okay? So it means that, well, if the balance is not done, okay, very well, if there's not enough renewable to deal with the demand, so the price goes up, naturally, because somebody needs to turn off some load, somebody needs to rely on the batteries, the local battery at the home. So, so that tariff needs to be designed, and it might be some people, like companies, aggregators, that try to deal with this like insurance they become like an insurance company of your electricity bill. So they give you a time of use pricing, and they take all the risk, but they do most of the management and the pricing for your smart appliances. So they take the risk, but it is more reliable for you. You know that you can estimate your energy cost per year. So
That's like a third party.
aggregators, they call it aggregators.
And
okay.
Is that happening somewhere in the U.S.? Are there communities?
They're looking at it in California. They are looking at it in the state of New York. They're talking about it. So it's happening. I mean, in Europe. So it's a way that, I mean, if you want to be fair to everybody, you need to design a better mechanism of transacting electricity. And there will be a cost for the power. How much energy, how much power you're taking, there will be a cost for that. Not only the energy that you're using, but the spikes of energy, the spikes of power that you're using. There will be a cost for it. So also the spike of the power that you're producing, giving to the grid. So because those are actually adding to the troubles of managing the whole grid.
Isn't there a way to manage the feed into the grid so there aren't spikes?
What do you mean the feed? You mean the
from the house,
electricity,
yes.
or yeah? If you have a small energy storage, you can do that. So you can take part of the power from your batteries and the part of that from the grid. Okay.
So you're talking a lot about batteries, and I am very familiar and comfortable with them because I live in a house that has always been off the grid,
Okay.
and so that's a normal thing. But most people on Oahu are not familiar with batteries,
Right.
and they seem a little scary or inefficient or something. But maybe you can talk about where we've come with the batteries.
We are driving cars that has battery in it, and driving is more dangerous than a battery sits somewhere. So it makes sense. I mean, battery technologies are advanced. There are technologies that are really safe, so there's no problem with them. So batteries are part of the solution. Batteries are part of the solution. What I personally think that completely go off the grid is expensive, because you have to have a huge amount of battery. You need to have space that you don't use. You need to put huge investment, but not going completely off the grid, because you don't want to have. You might have 40 days of rain.
Well, I have to say that a couple of our appliances, like the dryer,
Yes.
we have a dryer. It's gas.
Okay.
And we do have a little tiny Honda backup generator. And in the winter mornings when it's late, the sun comes up later and all of that. Somebody who often has to go out and start
Yeah.
the backup generator, and that runs until the sun comes over the ridge at 7:30 or whatever.
Yes.
But it's not a big deal. And
But you have something.
Our
Yeah.
batteries are old.
But consider that everybody is doing that, okay?
Yeah.
But if you connect everybody together, and if let a utility or somebody take care of those
So they don't have
extra
to
energy
go
that
out
you need
and-
that they cannot get from your battery, let them charge you good money, let them survive in the business, then everybody benefits here. So completely off grid is I think is more expensive than connected but work together. Because communication is very cheap and is very reliable now. Communicate with each other. Okay, not in a way that you ask me, okay, when you're cooking, your stove, naturally those things will be managed by computers, by artificial intelligence. So and at the same time, since you don't have to burn any fuel, your electricity is much cheaper because you're not burning any fuel.
So we're going to have a lot more people or entities generating. I can see in Hawaii, like all these open parking lots. I can't wait till they're all covered with photovoltaics.
Yeah.
But photovoltaics are just part of the solution. I mean, we've talked about wind, and we've talked before about stored water and using that. But all of those are larger systems. So keeping it back to the
Small house.
the house or the neighborhood. So the neighborhoods are going to have, everybody's going to have a little bit of storage, optimally.
Right.
That's what, and then upgrade the appliances, or there's an application that does the upgrade for you. Does that work? Like
The
you were talking
application
about
that manages your energy.
Right.
Your energy. That means that when you're using it gives you a price signal, or that okay, now it's a good time to wash your dishes. Automatically, it washes the dishes when you have more sun, right? Because predicts the sun, get the information from everybody, has a better understanding of variability, has a better understanding of variability in the island and the price. So it uses when it makes sense. It's cheaper. So and everybody will be coordinated naturally because everybody is coordinated with this price or whatever control signal which is managing all of these. So everybody is coordinated. Everybody is connected. So your appliances do their job.
So you're saying like we can put all the dishes in the dishwasher,
right?
And everybody goes to school and leave, and it will do the dishes when it's cheap to do the dishes.
Yes, and also it can
Wow.
wash your clothes when it's washed, and also at the same time it can dry.
Wow. Okay. Well, that doesn't sound too hard. It just
Okay.
means being flexible.
Exactly.
Okay. Well, let's be flexible and take a little break.
Okay.
Aloha and hello. My name is Anu Hittel, and I host a show, Climate Change Beyond Outrage. In it, we go beyond outrage to look at solutions to climate problems facing people, nations, and the world. Join me every Tuesday at 1 o'clock Hawaii Standard Time. See you then.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized right here on Think Tech. Aloha.
Aloha, I'm Kawi Lucas. This is Hawaii is My Mainland on Think Tech Hawaii. We're here every Friday at 3 p.m. And today I have Dr. Reza Ghorbani from the Renewable Energy Design Lab. And we've been talking about what it'll take to get us to 2045 when we are off of fossil fuels. And we've been talking a little bit about batteries, and there's legislation pending right now. It's crossed over, as we say, so it still has to go through meetings. And right now, it needs to go through the Ways and Means, and it is House Bill 212. And if you are interested in getting some batteries and would like to have a rebate, we want to pass this, House Bill 212. Again, you can look at cowilucas.com, and I'll have the links. We'll have an income tax credit for people who are buying battery backups, and that'll be a really good thing. But this bill has to be heard by Ways and Means, so Jill Takuda and Donovan Dela Cruz are the chairman of that committee, and we need to get that heard. So, Dr. Ghorbani, what else needs to happen? What are the other critical elements here to get us to this goal?
I think you have to make sure that the research institutions, universities in the island work with experts in the world, okay, in US and abroad, okay, invest on research and innovation, tell the ideas and concepts to the other, talk to the industry, okay. So, okay, this is our goal, this is the market, and this is a goal that everybody else will go, because naturally it makes sense to go 100% renewable.
Well, this sounds like something that you should be doing, that the Red Lab should be doing.
We are doing part of it, but we are small, we are tiny. So, also state needs to invest more on innovation. University of Hawaii is investing already on innovation. State
the energy accelerator, or how do we do this? How do we get from where we are now to?
There are fundamental questions that needs to be solved. We need to understand to address part of these questions. There are technological aspects. Some technologies needs to be done. Developed further, and there are businesses needs to be actually grow, like in the field of smart grids, smart appliances, communication, batteries. Robotics installation of solar panels on your rooftop, cleaning of your rooftops, make sure the batteries are always work very well, much cheaper internet, better infrastructure.
That sounds like a lot of jobs to me.
Yeah, it's lots of jobs. The energy independence from fossil fuel deals with everything. Social aspect of it needs to be understood. The human behavior needs to be understood. The prediction algorithms needs to be developed further, and artificial intelligence. Everything. It's a field that actually includes people from many fields, even psychology. So. On the other hand, the public sectors and private sectors needs to work together closely, needs to communicate further and better. HECO needs to say, oh, this is my challenges. These are really, I need to develop these demand response technologies. I need to develop these markets for electricity markets. I need to develop better batteries. So they need to communicate better with the research institutions, with the universities, and naturally, everything needs to work out together in order to address this. So, on leadership.
Yeah, leadership
is very important.
Well, I have to say that Governor Ige is certainly. I don't know whether it's because he has a background in engineering, but this is really, I think, the most exciting thing to happen in a long time environmentally for Hawaii. But you've mentioned so many things that need to be addressed, from psychology, and it's really nice to have someone with an engineering background talk about psychology, because that really is somewhere underneath what drives us and to make these changes.
Right.
Yeah. So how is your lab, for instance? How are you working to develop new technologies or interact with other researchers? How do you do that?
Well, we try to, we try to use modeling tools to understand the issues related to high penetration of renewable on the grid, the over voltage issues, really technical issues. So to understand the fundamental of it and say, okay, these are the critical problems that must be solved in order to address this, the energy management. So, and also on the other hand, we are trying to develop technologies like smart gateways. Smart gateways to connect your house to the cloud, and everybody else can be connected to each other. So your house will be connected to me. We can exchange data. So I can communicate with the utility in order to give the demand response flexibility of my loads to the utility, and the utility can put some incentive for me. We try to develop better technologies in more reliable and secure communication. We are working on smart appliances now to understand what it takes for your, any different appliances that you have in your house to be smart.
So retrofitting?
Retrofitting, and not only retrofitting, but also going to the actually fundamentally what appliances needs to be changed to be in order to save money for you as they work.
Are there any particular appliances that you would say
like
right
heat
now?
Pumps, like heat pumps, air conditioning units, they will be inverter based. Your water heaters, even your stove can be responsive to the change of frequency.
Okay, so what does that mean, inverter-based? I live in a house
Inverter-based,
with
yeah, inverter-based.
Not everybody does.
So yes, it's in your most of the, your cooling or heating systems like heat pumps or refrigeration. You have a pump that works, right? That pump is an electric motor that is connected to the grid. So right now, the switch turns them on and off. Then you have a spike in the power, and the power goes and stays there. But you have an inverter. Basically, what inverter does, takes the AC, alternative current from your grid, convert it to the DC, direct current, and control locally your pump, okay? And you can manage it in a way that you don't take spikes from the grid, from the AC side, from your inputs, okay? Reduces, and you can actually better manage the amount of power that you take from the grid. So it's not on and off, it's smooth, you can control it smoothly. So that adds a huge benefit to the grid because it's not an on and off device anymore. It's a device that can be changed. The load can be changed. You can still have your own, hot water at the time that you want, and a good, temperature for your AC, but you need to have flexibility.
So in addition to batteries, an inverter is another piece of equipment that most households don't have now, but will be part of it. And then this, the brain of it. There's some, whether it's
energy management units, yeah.
Energy management units.
Yeah, that's it. So what we are developing is a gateway which connects your house and appliances and your PV panels and inverter-based loads. And your PV panel has an inverter as well, so it connects the DC current from your PV photovoltaic panel to the grid. So inject the current to the grid. So, and the load will be inverter-based, which check the current from the grid to the appliances. Okay, so. The energy management units, okay, what it does, it predicts it tries to manage your energy use in a way that reduces the electricity cost in a long run. So it's an optimization that manages your loads and gives you lots of flexibility at the same time.
Do you know any place on Earth that these kind of systems are in use?
There are technologies, available, very expensive. It's like a comparison of taxis and Uber, right? So after smartphones are so cheap now, right? So then everybody can communicate, everybody can easily exchange data, and so this is the same. So the exchange of information is so low cost now and so cheap because of the internet and all the communication means that we have, that it facilitates all of these. So, and also electric cars. Electric cars will be a huge part of the grid. So
Yeah, I'm noticing that for the HB 2085, it's not just electrical generation, but it's ground transportation. So that's a
Right.
really big deal.
yes.
So I can see that that will take a lot of transition, but a huge savings.
Huge savings.
And so do you see a problem with, for instance, the load switching from everybody charging vehicles at home? Does that have a significant impact or not really?
Oh, well, the grid is designed for a certain amount of loading. Okay, so your transformers and the line and the ratings of the wires. So it depends. It depends on of where you are and how much electric vehicles you have. Definitely, it has impact on it. So you can. It's very difficult to have everybody's having EV in a neighborhood. So the utility needs to reevaluate and study and see what does it take for them to do that.
I can imagine that, might it be better from the generation side or distribution side to have the charging happening when people are
Have
at
more
work?
PV. So
or
it depends where the
during the
cars
day?
are, right?
Yeah, right. If you drive your car to work, as so many people do,
Yes.
if you are charging your car while it's sitting at work during the day, that might make more sense than charging it at home at night when there's no sunshine?
So if you walk in anywhere, you see cars are parked, right? So consider all of the cars, or 80% of the cars are electric. So what happens here is that you just need to manage them.
That sounds like, if I take one thing away from what you've discussed, and I feel like I've been in a bit of an electrical storm. There have been so many ideas, that it's really a question of management. This whole integration is we have to do our homework and the research around how to manage all the variables,
Yes.
in the energy.
Yes.
Okay, all right. Well, thank you so much.
Thank you very much.
I'm sure that there's going to be a lot more for us to learn and understand as time goes on. Thank you so much for coming. And stay tuned for Where the Drone Leads is on next here on Think Tech Hawaii. I'm Kaui Lucas, and have a fabulous weekend, and go look at batteries.